Hello, Max NG7M back for part 2 of the B26-RF2K Plus series. I started. This is obviously the second video, part 2, and I have my say hello to my little friend right here. And so I've got the B26-RF2K Plus sitting right here. The first video, if you found this one before the first video, you can find on my YouTube channel, and if you like it, give me the thumbs up. It goes through the unboxing of the amplifier, and it's long. If you're looking at spending this kind of money, I think you'll appreciate it. You can go through and see exactly how it's packed and everything else. Anyway, check out the first video. Skip around if you like, and hopefully you'll find it helpful. I've received a few emails, and this one should be more interesting. Gets into the assembly. There's really 3 things that you do. So without further ado, and I end up talking way too much, just a reminder, anything I tell you here is superseded by anything you find in the manuals. So you can see my sophisticated presentation software here, which is WordPad, and DH3 NAB Reinhardt and DL5 NAM Chris are to receive the real credit here for making this kit available to the amateur market. Worldwide, really, and there's owners now all over the world. And this is my build, and again, if you see that I did anything wrong, please comment objectively, and always double check the manuals on the www.rf-kit.de website. Not only there, but almost more importantly, sign up on Groups.io to the forum that's there. I touch on that in the first video. So again, whatever goes on here, this is August of 2018. You know, as the new images come out, things might change a little bit. And so as of the making of the video, this is the latest version of the amplifier as far as the PCBs are concerned, as far as the LDMOS MOSFETs are concerned, and everything else. So let's get to it. I'm going to do the same thing. I've got a bunch of pictures, and I'll just try to rip through those pictures as quickly as I can and stop and make comments as I go. So let's get started here. I will kind of move me out of the way a little bit. You don't need to see me much. You can see my desktop background is a shot of one of the coax solder areas there, and looks like I left a little flux on right there. Anyway, let's pull up a browser. These pictures are on a photo album I host on a server here in my shack, and there will be a link in the description of the video, just like I did in the first video, so you can find the pictures. It's nice as far as the gallery is concerned. You can look at small, medium, which are actually pretty high-res pictures, or if you want, you can look at the large size, which is the actual raw pictures. And I mean, nothing too fancy, but the picture quality is pretty good. There's some blur. I mean, I didn't spend a lot of time. I need to get back to playing with the amplifier. And this video, let me talk about that again. So it'll include installing of the fans, the Raspberry Pi, and all the coax soldering. It prepares the amplifier for first-time power-up. And so the PA is bypassed for the calibration, but I don't go through any of the calibration in this video. I'll do that in a third video and should have that out by this weekend. So after I do the power on, I actually did this last night. I powered it on for the first time last night, and I have the actual video of powering it up. I'll actually replay that video from last night in this video, so you know, it'll be like going back in time there a little bit when we get to the end of the commentary on all the pictures. So let me pull up the picture website. We're going to move this out of the way here. Again, there's a nice shot on the pictures there. If I can get that to come down. Let's see. And bear with me. So this is my picture gallery. You can see the latest pictures that have been added. And we're going to go to RF-KIT. I've got a section that has, I've got different areas here for some of the different pictures, but we're going to do the pre-calibration assembly primarily here. So I think I've got some pictures of the first time power, just stag pictures in another folder, just a couple pictures there. So here we go. Let's get the first picture pulled up, and let me adjust this so that we're kind of maximizing the size. I'm recording in 4K, so the video you're seeing of me is actually not 4K, but it does a pretty good job. But the desktop and everything on the desktop is in 4K. So if you have the equipment to replay that, you can, or you can obviously do the lower resolutions. So let's get started here. On the forum website, there's a nice fan document in the file and manual section. You'll want to look at that. NU6X, I think, put that together. He worked on the manuals too, and I hope I didn't slaughter his call sign. In fact, that makes me want to go look at that. So let's just go look on Groups.io quickly here. And I know the resolution, this might be a little small. So I'm just going to kick into the file section, RF-2K plus, and the fan document is under manual. You can see it right here. It's a fandoc.1, and it's Mark, November United 6 X-ray. So hey, I remembered his call sign. So Mark's done a nice job, I think, tweaking some of the English in the manuals, and where everything's actually out of Germany from Chris and Reinhardt. So and don't worry about the language problem. It's there's a little bit of difference there, but it's the world we live in, and they've done a nice job with the manuals and documentations. Keeping in mind it is a kit, right? So you're expected to be somewhat technical and dig in and figure things out on your own. So yeah, I mean, it isn't like something you'd get from a mega manufacturer on the manual. The fun thing is it changes, and it's easy to update and see all the updates. So check everything out here. That's, again, anything you find on the website as far as the manual supersedes what I say, and make sure you double check anything I recommend and do the right thing. So far it's been pretty good for me. So back to the picture here. This is one of the recommended fans, and what I did here was I actually retained the third wire on the fan. The amplifier only uses voltage to control the fan speed, and based on Mark's recommendation, I got these particular fans. They're the and I can't even remember the name. They're about 20 bucks a pop, and got a box right here. I hate to digress and kind of get back to the other video, but that's the fan. All the details are in that fan document. So let's get back to it. So you'll see in these pictures, I just coiled up the third wire. It's probably never going to get used, but that's what you see in the yellow shrink wrap here. And the cable's coming out here. Let's go to the next picture. Here's the end. I ground it off so it looks a little nicer on the front B26 PCB. And this is the rear fan, obviously, because on the fan, these wires were bare, and so I put shrink tube on here, extended them out. So, and you can see that there. So I cut the end off because I knew I was going to have to extend the wire to put it in the amp for that rear fan, because the control is going to go up to the front of the amplifier on the B26 controller. So now this is one thing I didn't know about when I did the unboxing, but I had read documentation, and Mark's work showed that having an empty fan shroud between the rear fan and the heatsink actually made for quieter operating and more efficient operating. You had more cubic feet per second of air going through there, and so I just kind of followed what everybody else was doing and took an old fan and cut it out with the Dremel tool, and cleaned it up, made it look nice, sanded it up, and you'll see that towards the end of the video where I actually get the fans installed and everything. Now, one thing I did that I wanted to talk about was once I extended the fan power connection, you can see that the third yellow wire ends right here in this shrink wrap. On the empty fan shroud, which you can see right here on top of the rear fan, I wanted to use the slot that's in the lower left-hand corner, facing from the rear, of the amplifier. And I'm not sure if that's been there all along. I know they made some modifications. But come to find out, there's already a blank fan installed. So now I have 2 fan shrouds. I'll talk about that later. I can remove the one that I added. But anyway, I fabricated this fan, the blank that I made, because I wanted that wire to go through the bottom slot that was on the amplifier. You could probably route the power cable right through the, the same slot on the blank fan shroud that is shipped with the amplifier on the newer amplifiers. But I wanted to be able to remove those fans and easily slide the power cables out from underneath the heatsink. So you'll see that later on in the pictures. It took a little more effort, but I had the time, and I wanted to do what I thought was a clean job. So again, just showing that slot, because this will be the back of the amplifier. We'll press down, right against here and push the power connectors right up into this slot right here. And then the slot in the aluminum on the back of the amplifier will be down in this area. So a couple more shots. I used a jig to solder those wires up. Wanted a clean job. Anybody that's doing a lot of soldering, you really need a syringe with some flux, and it makes for nice solder connections. And just showing you how I use the shrink tube here to extend the power connections on that rear fan. And there is the connection right there. It doesn't look like I have the other end on so far, so I've got the extension, and then I'll put the end that has the power connector back on. It must be in a later video. So this is actually the shroud that's shipped with the amplifier, and so in the back of the amplifier there's a cutout here, and so I wanted to use that cutout because this would normally block it off. And so I just with the shroud slid back into the slot in the back of the amplifier, and scored in this rectangular slot here, and then used a Dremel tool and did a little fabricating here and cut that out so the slot was open underneath the fan shrouds and then underneath the heatsink. So here you get a good shot of that. So here the blank fan shroud that's shipped with the amplifier is right here. And I didn't know why it crossed my mind, but I just was bent on putting my own blank fan shroud in. So there's actually 2. I keep repeating myself there. You can see that little fabricated section that comes out. It'll allow this slot right here to be open so the power, the wires can go right underneath there. So I just thought it was a nice clean approach. Another shot there. And here you can see a little better. So this will fold down here as the blank fan shroud in this case, or the actual fan if you remove this, will lie right down here and go in that slot. And so here you can see the nice clean setup. So you see the heat shrink I put over the wires here. They come straight through and then fold down and right into the slot there. So and later on I'll show you the hardware that I ordered separately too. So I could use one 90mm M3 or 3mm metric bolt to go all the way through all the fan shrouds into the heatsink. This is the front fan of the heatsink for the amplifier. And I dremeled this area out right here so the rear fan wire could slide underneath there. And so here you can see I've removed the 3rd wire on the fan that mounts in the front. And here's the power connector. I just ground those key slots off because the PCB is not slotted. More on that later too. You have to be real careful and make sure you get the polarity right on the fans. So this turned out nice, and so it's easy to pull the wire out from underneath the heatsink there. And so here is I've just test fit the front fan. So now we're looking at the front of the amplifier right behind where the Raspberry Pi would sit. So this is one of the standoffs for the Raspberry Pi. And so you can see the extension I made for the rear fan coming right underneath the heatsink right here behind the fan, and right through that slot that I just dremeled out right here. And then this is the power wires for the front fan. No need to do the extension there, I think. So here's just another shot there. And here's a top view looking down the right side of the amplifier in the front. And it looks like if the pictures are in the right order here, just some basic shots of soldering and making those extensions. And now you can see that. I remember I didn't extend the main fan power connectors, but in hindsight, I think maybe I should have. I could have used a bigger ferrite. So I'm particular about making sure where possible I'll use mixed 31 ferrites to try to limit any common mode interaction. You know where these wires would act as antennas. So I'll put common mode chokes on to keep that RFI off the wires. So again, in front of the amplifier, here is a shot that just shows you from the back of the amplifier. I made the extensions right around 57, 58 centimeters out, or 22 and a half inches. I would maybe, in hindsight, extend both of them out so I could get a bigger ferrite around these two power leads for the fans. Up to you. Most guys won't put the ferrite on there. You'll see later on that I'm big into the ferrites. So you can also see that I removed the B26 controller board here, just so I had good access up to here. And it was a little tricky on this screw right here, getting the nut back in there without having to take the whole mounting panel here off. So anyway, that gives you an idea of the extension on those. I just use heat shrink to tidy it up, make it look good. And here's another shot of that. So that's how long I made those wires. So they both came out the same length. You can see the ferrite ready to go there. And here's another shot of the back. And I'm jumping around a little bit here. I don't know if the pictures showed up in the right order. I was working on the front of the amplifier waiting for some of that hardware to mount the fans in the rear. But I tidied up all the wires here, and this was really nice because this is an open spot right next to the DC switching power supply right here. Here you can see the fan from the front. So again, I'm looking from the front of the amplifier. Here you have the B26. This is the coax coming from the back to where the controller needs to sample the, it's the frequency counter input to the B26, if memory serves me correct. Anyway, but the medium-sized mixed 31 ferrites here, these are medium-sized snap-ons. This worked out really well. I separated kind of the control wires where you had there's a USB going to the back, and the Cat 5 cable, that you'll end up plugging into the Raspberry Pi. So I separated the wires that go into the B26, except for the 5-volt power wire that comes out right here that actually powers the Raspberry Pi. And I actually was able to get 4 of these medium-sized mixed 31 ferrites on. So I clamped one on and slid it back, clamped another on, slid it back, 3 and 4. So there's 4 on there. And then on these wires, I was able to get 3. So there's a total of 7 ferrites that I've clamped on those wires. Hey, and if it's not necessary, it makes me feel better, Get rid of anything stray there if there's any RFI. So up to you if you want to follow through with that. So 7 ferrites are back in there when you see the front of the fan earlier. Tidied up the cables here. One's going to the RF pallet, and the others are going to back of the amplifier. 2 serials, and I think that was it. There's 3. More shots of that. And so here you can see I've got all the ferrites in there. So there's 4 down this side, 3 down this side, and I tidy this up a little later. And you can also see here I've got the smaller ferrite on the power leads for the fans, the front and back fan. And there's the Arduino. And here I also have the 80 millimeter fan installed, and then the 60 millimeter fan here installed on the power supply. And on the first video, I thought this was open here, but there's a nice adapter here. You're actually adapting the 60 millimeters down to you know, smaller. It's more like a 25 millimeter, 30 millimeter fan shroud that's gutted out from the power supply, so you have more airflow going through the power supply. So, well, I'll keep going here. Here is the power lead to the B26 for the 80 millimeter fan, and I threw I mean, I had room. I just used the stock cable here, and there was plenty to get a couple. You know, I got 3 turns through there on that mix 31, and then tied this ferrite off to this hole right here so it doesn't flop around. And another shot of the 80 millimeter fan. Tidy things up there. Here's the fan on just in this shot. Keep in mind that the center pin is always positive, and on this side of the B26, the you know, no connection is on the right side, and the control ground here is on the left side there. And so just pay really close attention to the manual when you're hooking up the fans, and then you also want to test the fans, make sure the wires are what you think they are, positive and negative, and the rotation of the fan is what you expect. You want from the front, you want the fans blowing air towards the back, and then the fan on the back, you want air pulling out of the back of the fan. It's all in the manual. So just a good shot of that. Another shot there. One from that side. Close up of the ferrite, and this is sitting pretty nice right here with the Raspberry Pi. We'll get to that in a minute. Another close up of those ferrites. I ended up tidying this up even a little tighter there. It looks great, I think. Shot of the back, or excuse me, this is the front of the amplifier, and so this is the front fan, 120 millimeter fan that's on the front of the heatsink right on the RF pallet. You know, you've got the copper heatsink here, and just showing the fan there. The manual, they say you only need to use 2 screws here, but I took the time and put all 4 of the screws that were installed on the rear fan up on the front. So there's 4 screws installed there, because I was going to replace the screws on the back, which you'll see later. This is a jump to, and there's been some discussion on the forum about this. I found a nice metal case for the Raspberry Pi and drilled out holes to mount it on the standoffs that come in the amplifier base. And the case is not touching up against the front panel, but it's very close. And so there's potential to maybe inhibit some of the airflow. I think it would be minor, but I went ahead and drilled a bunch of holes here. It doesn't look quite as pretty, but later pictures, and you might see all these holes I drilled in here, and then on the cover that goes on the case. It does look nice. In hindsight, I don't know that I would have done the metal case. And really, the only negative I found is I had to, you know, do a few little tweaks on some of the cables to get them to fit in, you know, nice and snug. The HDMI cable was fine. By drilling the holes, I just have a hard time believing there would be any airflow problems. If there are, it's really easy to take all this out. So nothing was modified. I just pull this out and then screw the Raspberry Pi right down into the bottom here. So one comment on the Raspberry Pi. In the first video, I talked about how you had to have a Raspberry Pi 3, not the Plus. But I looked close at the release notes on the latest image that came out. It was like a week ago. It was right at the same time the amp was being delivered. But the new image now supports the Raspberry Pi 3 Plus. So I highly recommend you get the new version, a 3 Plus. I actually ordered one because I can't stand it, but it's a higher clock speed. The Wi-Fi is actually a lot better than the Raspberry Pi 3. So your Wi-Fi reception and transmit's better. And I think there was some better RFI shielding and some factory heat sinks on either the CPU or maybe the video chip that's on the Raspberry Pi 3 Plus. But you should get the 3 Plus. It's like 200 megahertz faster, and so it might boot up quicker. You'll have to use the latest image, though. There would be no going back to those previous images, I assume. The new image will work on both. So a little bit of a digression there. So just some shots of this case. It looks great. I kind of hacked it up when I did those holes. Shot where the ferrite there is for the for the fans. You can see over here, just there might be a better shot of a picture later on, but on the two rear fans, they are in parallel. And again, the positive and negative, positive center pin, the no connection is on the left side, which is opposite over here. So actually there's both fans. So the center pin over here, the no connection is on the right side. So I believe pin 1 is the no connection. Anyway, just check the manual out and make sure you get it right. I'm confident this is exactly how it should be. So I know there's been some guys that have had to replace some transistors because of polarity problems on the PCB. So these, one of these little transistors got fried or something. Anyway, I didn't want to have to deal with that. This is a shot of the Raspberry Pi installed into the metal case. You can see how I've tidied up all the cables over here, just zip tied them down, made them look nice, tied them all up. And this is the micro USB that goes to the 7-inch touch screen. And here is the HDMI cable. It's just laid up over the top here in front of the, you can't really see it here, but it's folded back and then goes right into the Raspberry Pi right here. So you can see it's tidied up pretty nice. I did have to, on this, the power coming from the B26 board, that's this micro USB cable right here, coming down here, and it comes out right here, and I think I take it underneath the Raspberry Pi. Anyway, I did Dremel a little bit of the connector away. I mean, it didn't get down to the shield or anything, just so the USB coming from the Raspberry Pi 3 into the Arduino fit in there nice and vertical. Anyway, I thought it looked tidy. Taped up these ribbon cables here. I think it looks nice. There's another shot there. I ended up actually installing all the bolts here too. Not necessarily needed, but I did it anyway. I even went to the extent of drilling the other 2 holes for the adapter that bolt into the empty shroud right here. So this is a gutted, smaller fan shroud here that the adapter bolts into. So I just had to drill through the metal plate on the front of the power supply, and then I got all 4 screws into that shroud. So it's just a complete solid fit there. This is the power on connection that goes to the switch, and so you can see the tab connectors on the back of the front panel. That's that cable going up there. All right, let's keep going. Another shot there. There's actually the just compression fittings for the tabs on the power on connector toggle switch on the front of the panel. And there's a good shot of it all tidied up. I now have a bunch of holes down here in the bottom and on the back and on the top of the case, so air can flow through underneath and through the middle of the Raspberry Pi in the metal case. That's a good look in front of the amplifier without the front panel on. Another shot. Here's the top of the case without the countersunk screws in it. And there are the screws in there. I whipped up a little label here that is gone now because there's a bunch of holes drilled here for the fan, the air to go through. Just some more shots there. 80mm fan. Oh, okay, so that's pretty much it for the fans. You'll see some details on the rear fan installed later on. So, and it may jump around a little bit here. So here's the Teflon coax that ships with the amplifier. And you need to cut, if you have the antenna tuner, which I do, so I'm not going to talk to not having the antenna tuner. You cut 3 pieces that are 6 inches, or off the top of my head 150mm, and then one that is 10 inches, which is about 255mm. And one thing I want to mention here is the manual states that you want 5mm here, 4mm for the inner insulation, and then 5mm for the outer insulation back to the outer jacket of the Teflon coax, which, maybe some of the early boards had wider spacing, but it was way too big for my taste based upon the where you solder these on to the PCB. And so I actually used a 4mm, 2.5mm, and 4mm, which I think is like the perfect fit. So just so you know, they're right. 4, 2, and 4. And don't think you just, there's actually a section in the manual. You go to the appendix, there's a good section on the order how to cut these and solder them so you keep the outer shield intact without, you know, messing it all up as you cut the different layers off, because the inner insulation is actually really tough to get off the center conductor there. The outer insulation is easy, you know, just using a sharp X-Acto knife or box cutter, you know, get a fresh blade out. Then take your time. This took a little time to do it right. And then you want to tin the outer braid on every single connection. So again, there's 4 coax that you'll be soldering on. Just another shot. This one is tinned, the other ones are not. Here you can see all of them are tinned. And I think I got a little better as I progressed maybe. So this is a 4 millimeters to 2.5, 4 millimeters on all pieces of the coax. Another shot there. Here they all are tinned up. Pretty exciting, eh? Okay, so here's the first set of coax soldered to the antenna switch that's on the back of the amplifier. So this is looking from the front at the bottom of the rear panel, which I have removed and laid back a little bit. Now, I actually soldered these, and they were not in a horizontal position, so you can see there's a little bit of solder here that ran down. These are the least pretty of my soldering skills here, but I mean, they still turned out nice. You really need a flux. Use a high quality solder. I use a very thin solder so I can control how much is going on there, and then I clean everything up with denatured alcohol after to get all that flux off. So it's a nice, makes for a really nice solder to the, you know, the tab or the location on the PCB. So here you have one going to the ATU, the automatic antenna tuner, and up top, right, this one will go to the top PCB. This one goes to the bottom, the low-pass filter on the bottom there, and this one will go up to the ATU. So there's another shot there. It was a little tricky. I took the back off, and because I had put all those ferrets on, it was a little trickier to lay that out, and I didn't have quite as much room to operate there. In hindsight, I would have maybe done this part first before you know, messing with the fans, and then I mean it's kind of half a, you know, 6 of one and half a dozen of another. As soon as you solder up the coax, then it's going to be a little trickier to have some wiggle room on that rear panel if it's not connected, right, to get in there and work around. So here is a little better job here on the soldering as far as the shield. On those other 3, you could see that the front of the shield had separated a little bit, but this is the kind of solder joint you want, and this one's been cleaned up. There's a little bit of flux left on there, but it's cleaned up pretty well. Another shot from the top here, you can see from the this is actually the low power, the low pass filter, the bottom PCB. So the center coax right here, this connection goes to the LPF out, right? And then this one's going to go up to the top to the antenna tuner. This one will go up to the top to the antenna tuner, which you'll see later. Okay. There's another connection down over here that actually goes up to the output on the amplifier deck, or the RF pallet up there. Here's a nice shot. Then maybe I cleaned that up better. I must have done a little more cleaning on with the denatured alcohol. But these coax wires, as documented in the manual, can take a lot of heat, but you don't want to get crazy. I used a nice soldering station with a bigger tip, and again the flux, and a small thinner good solder to, you know, feed in a nice amount and get these nice solders there, the soldering to the tabs. There's a good shot, one that's for the most part cleaned up on the low pass filter board on the bottom, and another shot. So you can see, I even ended up trimming these a little bit. So these were 4 millimeters. So I trimmed them to kind of match those tabs and leave the center shield, you know, between that and the outer RF shielding on the cable. And so here you're seeing the 2 pieces of coax going to the switch, the antenna switch on the back. This one will go to the antenna out, and whoops, clicked. This will go to the antenna out. This will go to the antenna in, and this one is coming off the, or actually it's the input from the RF palette output into the low pass filter, you know, underneath the antenna tuner. So anyway, talking and talking here. Just some more shots before I soldered these up to the antenna tuner here. So this one right here, again, it's coming off the low pass filter, and for calibration you'll take a temporary cable from this BNC right here on the antenna switch here, and you'll temporarily solder the shield and the center conductor together to do your calibration tests. So you bypass the amplifier deck palette directly. I also, at this time, I had this is the positive and negative 50 volt DC cables coming from the switching power supply. They're not connected to the RF deck there. All right, another shot there. There, my solder job here on the antenna switchboard doesn't look so bad at a distance. It's just that the front of the shield kind of came open just a little bit there. Not to worry. And another shot. Okay, now we're kind of jumping to the fans. I didn't get the right order in the pictures here. So I'm assuming we're going to come back to the soldering those other coaxes back on. So I wanted single bolts for the rear fan. And again, there's 2 shrouds that these bolts are going to have to go through, plus the actual fan. And then just Amazon's your place to get all this stuff. These are 90 millimeter. They're like the perfect size, 90 millimeter bolts. M3 3 millimeter thread, just the standard 3 millimeter thread. And they're just black. I can't remember the finish on them. They'll be fine for indoor use. And I had a little washer kit to get the washers on the back. So here, kind of digressing back to the installation of those rear fans. So here you can see the bolt, the 90 millimeter bolt, going all the way through the fan shroud that came with the amplifier that I'd machined out, and the power cable coming from that rear fan comes down here. It folds back through the slot on this empty fan shroud and then goes in the bottom there. So it's this nice free fit of the power cable that slides right underneath the amplifier. It would have been trickier trying to, you know, get all that through the other fan shroud. I guess you could drill all that out, but I just think it looks a lot nicer. And you'll see when it's all tied, you know, screwed down tight here, that's gonna what it'll look like. So here's just another shot before I screwed it all in. You can see the you know, the fan guard back here. So here you can see how that folds through that slot, and then it just has a nice fit right into that slot along the back there. So this is, I've got the fans on now, just some shots of that. There's the back, or the fan on the back. I shouldn't say fans, but there's 2 of those shrouds. And so there you can see it done up there. And here you see, I just think this looks nice. It doesn't go through right here and then down or whatever. It's going right through that slot on the rear there. I think it looks nice and tidy. More shots. There's underneath. You can actually see the slot here. I could probably loosen the fans and slide them down and actually get that to cover up. But anyway, another shot of the rear. This is, I'm sure, before I soldered in the. Oh, I know these are the right order because I put the fans and everything on before I soldered the coax to the antenna tuner on the top. So that makes sense now. What was I thinking, right? I had these fans flop around on the back because I had the back off to solder the other coax on. So I haven't soldered anything on the antenna tuner yet. So just some more shots there of the fans. I may remove this. And here's a shot from the left side rear, so you can see the low pass filter out here. And then this is the RF from the amplifier deck coming in way back there. Okay, and there you can see that. That's the input. Another shot there. Another shot coming from the RF deck. Okay, so here's a shot now. I've got everything on the back panel's on, I've got the fans on, those 90mm screws, yada, yada, yada. And here's what it looks like before I clean the flux off. So here you can see my soldering job as I hooked up the 2 pieces of coax that came from the antenna switch PCB on the back there. And so here I just use a brush, fill up the cap with a little denatured alcohol, brush all this off, and then wipe it off with the cloth. And you can see it's just nice, a little more professional looking. I missed a little flux here. In fact, this is the shot that's on the desktop, I think. Yeah, it's just rotated. So there's a good shot. You know, if you can get your solder work to look like that, you're good to go. Just a nice looking connection there. And so there's the top of the antenna tuner. Yeah, it looks nice and clean. So you can see the outer piece comes up here to the input on the antenna tuner, and the piece of coax on the left side, or it's from the front, it's the left side coming up to the antenna tuner out. And then this one goes down to the low pass filter too, down here. Right, it's the and we're getting close to the first power on here because I've got the bypass of the RF deck. You know, this is all documented in the manual. So I just tacked these on here, a little solder up here, taped them together, make it easier to solder. So that's ready to go. It's still on the bench here. And here's the directional coupler, RF deck, you know, looking pretty good. I've got the 50-volt power supply hooked back up. Here's a shot of the front panel on because I'm getting close to powering this on for the first time. Got the HDMI connector in the touch panel on the front, and here is the USB connection coming from the Raspberry Pi, the micro USB plugged into the connector here. I'm assuming the touch control, I didn't look up, you know, read up on it, but the touch panel control, I suspect, is not going through the HDMI, obviously. So it's, you know, this is powering the LCD and also handling the touch control capabilities, I assume. Just another shot here. You can see that I have all 4 screws in the 60mm fan. Another shot from that side. There you go. And the toggle switch for the power is hooked up now on the front panel. Everything's nice and clean. Kind of see the top of the metal case for the Raspberry Pi. And it's ready to go here. I still have it on the bench because I need to build the AC power cable. That's next. Oh, so here we go. AC power cable. You got detail. If you wanted detail, I'm giving it to you. So this is this is a nice power connector on the back of the amplifier, which is, most amplifiers, they won't have a, you know, an AC power cable that you can unplug. This is really nice. You could have one plug that's for 110, one that's for 220. But it was kind of a tight fit, and here I'll show you. So here's the plug taken apart, and it's really, from what I could tell, it was designed to have terminal connectors in here, which you'll see what I did here. And so I used terminals on here that were crimped onto the wires for the 220 input here. So here you can see it. So I've got just these eyelet terminals here crimped on to the wires. You know, here's the ground, and then you've got the neutral and power here. So there's another shot. Depth of field wasn't great here, but you get an idea. It's pretty tight here, so you got to cut and strip, somewhat careful there to get a nice clean job. And so there it is, all put together. Power cord I used is orange. I also put a 2.4-inch mixed 31 ferrite, as a common mode choke closer to the connection near the amplifier, just to mitigate any transients, common mode RFI that might get into the power cord. I have the ferrites, and so I wanted to do it up right there. This certainly doesn't hurt to have this on there. So there's another shot of the ferrite, and there's the power cord. I used 8 feet, and so I probably lost 1.5 feet, if that, putting the ferrite on. And so this is the US standard 20 amp 220 250 volt plug. And okay, so I've moved the amplifier off the bench. You'll hear in the video that I'm going to show you where I power it on that the W4 Echo Echo Yankee W4 EEY. I saw in his videos that he picked up one of these Tektronix scope stands, and it's like it was made for the amplifier. So that was nice to set it on and work on it at times when it wasn't on the bench. But so anyway, you can see it all wired up here. I've got the Cat 5 coming in for the network, which goes up to the Raspberry Pi. And I think it's all ready to power up here. Just some more shots there. And that's it. Yeah. So let me go back here. So now what I'm going to do, which is kind of, if I get this right, I'm going to play a video that will be full screen, but it was taken last night, okay? And so now you're seeing me, big here. So I'll turn off the audio that you're hearing now for my mic input, and then I'll play this video. And just a qualifier on that video, when I took the video, the way I just used my iPhone, and the reflection in the screen on the front of the amplifier wasn't very flattering. You'll get the drift. So I have some cuts in the video of the screen when it wasn't powered on. So that's probably too much information. But this truly was the first power on. I mean, I didn't do any doctoring here other than cutting out those sections when the reflection just didn't look too great in the screen. The other thing you're going to notice in the video is the first time I powered it up, everything was great, but there were some errors that came up on the first power up, and I think that has to do with the file system getting created. I was using the latest and greatest image. I did not use the image that shipped on the micro SD card because image 55 came out right after I took delivery of the amplifiers. So I was doing a clean start with the latest and greatest image that supports the antenna tuner. And on that first power up, it got to the point where you get a message box and it wants you to say yes to program the Arduino, and it's like the touchscreen wasn't working. So that's the only hiccup I had. Just the touchscreen wasn't working. And so I powered off the amplifier, and when I powered it on the second time, everything came up clean. And once I got back to that point where it knew it needed to program the sketch to the Arduino, the touchscreen worked. And so I posted a message on the forum, and one guy came back and said, no, it shouldn't work that way, but the reboot took care of it in my case. So that was the only little snag I had there. So let's go to the video. I'm going to turn the audio off here, and then I'll start the video, let it play, and then I'll come right back. Maybe. Okay, let's try this again. Okay, let's try this again. I'm going to turn me off. And let's see if I can get this video to go here. Where is it? Oh, bear with me here. Shoot. Order. Okay, that is on the top. Okay. And let's see.
W4 Echo Yankee, I think his name's Gary, W4EEY, had a picture of one of these Tektronix scope carts in his videos, and I found one on eBay and got a steal on it. It was a deal, and it's like it was made for the amplifier, just like W4EEY said. Anyway, the amplifier's set up for the first time power on. The palette, the PA palette has been bypassed, so there won't be any anything going to the palette there. Of course, there's nothing hooked up anyway, so there's the back. The newer versions, come to find, I already had the fan shroud in here, the extra fan shroud. I didn't know until I'd already kind of fabricated everything to have a second fan shroud. I wasn't even thinking, but so now there's two empty fan shrouds. I can take this one out easy enough. I also just used 90 millimeter 3M3 bolts here, metric 3 millimeter bolts, so I could have one bolt go all the way into the heat sink. So anyway, there's a power cord. I got a mixed 31 ferrite on there. I think I crossed all the T's and dotted all the I's. Let's see what happens here. Turn it on. I'm going to pull the screen off. I haven't even had the screen off yet since the assembly. And one thing to check, I know, just based on reading the manual, there's a little power switch on the back of the touch screen, and it is in the up position, which is on. Just to double check that. That's right there. So you can see the temporary SMA connector going to the coax that comes out of the low pass filters, right, that would go into the PA. Okay, big moment of truth. Gonna fire it up. Oh, I see something on the screen. That's a good sign. So far, so good. Raspberry Pi. Oh, and it's booting. Uh-oh, danger. Descriptor read error. I don't know what that was. This is the latest image. There's a new image that fully supports the antenna tuner. So let's see if it comes up here. Oh, this is a good sign, right? It's firing up. Arduino is programmed. After that, a restart takes place. Now, it looks like I'm going to say yes. I haven't looked at the calibration manual yet, but okay. So, okay, it's firing up again. Same message. Arduino is programmed. After that, a restart takes place. Oh, that time the touch screen worked. There we go. Update is started. So that first go around, the touch screen wasn't reacting. Not a big deal. So I think actually now I can tell this is programming a sketch to the Arduino. There's an Arduino Mega 2560 in this. Restart Arduino. That was honestly the first time I powered it up, so everything's good so far. The only little snag there was it's like the touch screen wasn't registering my, as I pushed it. Let's see what we get this go around. Let's fire it up. Oh, heard some relays clicking. That's a good sign. Oh, and there's the screen. Sweet. So, excellent. Then I've got more fun to do on the calibration, but it's good. It's a beautiful screen there, as you can see. 7-inch LCD touch display. So I'm still waiting on the case cover. It's out getting powder coated from a guy I've used before. And then I'll put on the front cover too from W4Y, and I think he's the guy that did the front panel. But pretty cool. It looks like the fan is going down on the power supply now. Of course the 80 meter fan is not running, and the PA fans are not running as you'd expect, but the fan is just running silently on the, I don't know if you can tell there, it's on the power supply. You can see the fan blades there, so pretty cool. Alright, it's in bypass. Let me put it in operate, see what happens. Oh, ATU bypassed. Yeah, that's what we want. And well, I need to go through the calibration, so we'll call that good. Hey, so success, pretty cool. And we'll keep going with the videos with my experience here, NG7M.
Okay, you should be back here, and hopefully that sounded all right there. And I'll make me smaller again. I want to go back to a couple more pictures. We're almost done here, and sorry about it. I kind of fumbled around getting that other video to play. But one thing that was interesting is I noticed in the background of the video you can see my SPE 2K FA. So you've got a shot of the you know, the amplifier. Obviously we're focused on here, the RF-KIT, and in the background you can see an SPE 2K FA. So hopefully I'll get to do some comparisons there on the IMD products, see how they compare. So let's go look at some static pictures of the screen. If you go back to my photo gallery here, I've got a section on first time power up. There's just like 3 pictures in here, and just a static picture of the front of the amplifier. Here you can see all the holes I drilled in the side of that metal case I used on the Raspberry Pi 3. Again, we'll see how that goes. I'll rip it out if I don't like it. I spent 20 bucks on the case, so I'm compelled to try to make it work. Here's another shot, close up. In this shot, you can see that I've changed the, put my call sign in. This is a feature of the latest image. You have to do that through VNC, which when I'm done here, I'm going to connect to VNC and I'll show you. We'll power on the amplifier, live in this video, and I'll connect up with VNC. Let's see here. This is the last shot here I'll give for this part 2 of the video, and hope you enjoyed this. If you're looking into one of these, it's a really cool kit and a lot of fun. So the next video segment I hope to get done as we get into the weekend here will be the calibration process. So I'll go through the calibration steps. I think that the document is fairly long. I want to say 22 pages or something like that, 24 pages. But before I do that, just a reminder, this is just so cool. You have a full SQL board computer here in your HF amplifier. And so when I plugged in, I'm hardwired in. I didn't do Wi-Fi, but I've got Cat5 run to my hub here in the shack. And you can go through the setup on the screens. Here you'll see the IP address that's assigned. And in my case, the last octet of the IP address was 150, so I knew exactly what port and what IP address to hit with VNC to remote into the Linux operating system here. So let's do that right now. I'm going to minimize this. All I did was, I have experience with, here, I'll move me up over here maybe. VNC, there's a distribution called Tight VNC. So if you just Google Tight as in T-I-G-H-T VNC and download that. It's a quick install. It's right here. I'm going to fire this up. And so if you're not used to Tight VNC, this is just like a remote desktop, RDC, remote desktop connection in the Windows world. So you're going to remote into, the the window manager of a Linux operating system. So here, you probably can't see this because of the high resolution, but I have my local IP address 192.168.1.150, and I'm going to connect, and it defaults to port 5900 if I remember right. And so when I connect, I got to power on the amplifier. What am I doing here? Let's power it on. So if you can see in the video here, I'll make that big here. You can see it. Did you see the screen come on there right down here? It's powering up. You can see the little raspberries right there. RF-KIT's powering up. And Titan VNC just timed out. So the operating system's booting. I'm familiar with Linux, so I went in and updated the distribution, which changed the desktop background. So you normally won't see this background there on the distribution. But I could make a whole video on the fact that this is running Linux, and you could play chess on your HF amplifier, or games, or whatever. It's really cool. So now I'm at the default amplifier screen there, and let's try this Titan VNC again. I didn't have anything to connect to, so we'll move me up here. And guys, if you're hanging in there, I'm almost done with this segment, part number 2. Pull up the Titan VNC. You can see it right here, and I just minimize some stuff there. So now I should just connect on the default port. It should ask for the password. There it is. It's asking for the password. And there we are. There is the amplifier. It's as though I'm looking at the front of the amplifier. So here I'll just kind of moving the wrong window around here. Just trying to adjust things around. I'll kind of put me in the center and put it down below here. So just very cool, right? So here you're looking at the application that's loaded at boot up of the window manager in Linux, and you can go to the menu here and jump in or close. One thing I did notice on this image 55, and I think it had to do with when I very first powered up and I was using the touch screen to go into the menus here, and you'll see back here things change here in real time as I work the display of the amplifier from VNC here, Titan VNC in my case. There was like a lag in the menus, and I saw some guys posting on the forum today talking about that with the 55 image, the Fumfsich image. And I think it might have been related to, I'm guessing that it's like the DHCP on the Linux operating system was looking for an IP, and for whatever reason, it wasn't very interactive. But as soon as I had the network cable plugged in, it didn't have that problem anymore. So just some conjecture on my part. So again, you can go to the menu. You've got update. You can check for an update. You can reboot the settings. Go to the settings tab. And here's where you do the personalization text. You can tell the actual English language here is just a little bit off, but not a big deal. This is the only way you could put in your call sign here, or whatever you want to put in. You have to use the VNC interface. There's not a keyboard interface like there is on the touch panel for connecting to a Wi-Fi network. So anyway, you've got antennas. You've got the LAN, Wi-Fi, and VNC. This is where I saw the IP address that was assigned by my router, and you're seeing my MAC address there. I don't care. MAC address for my Wi-Fi card too. And the default port is 5900 here. You can change the port if you want. You can change the VNC password here. The status screen is really nice. I know this is used during the calibration. I've since read up on this, so you'll be looking at that. It's nice to, you can actually take the front panel off, disconnect the touchscreen LCD and the power to it, let it boot up, and then just remote in and do everything with that front panel removed, so you can work on the multi-turn pots. I'll talk about that in the calibration video. Status, actually it was the debug screen I think you use during the calibration process. And here's where you go into the rig control settings, for another video. and then the hardware. Obviously, the image and the software supports some of the different RF-KIT PA modules and low-pass filters and the antenna tuner board. So, boy, that's it in a nutshell. You can actually, like you would in Windows, you can close down the RF-KIT application by Alt F4. And so I just closed down the app, and then by default they have a link to fire up the app right on the desktop. So I'm going to fire the app up again. But I could, it's, I'm in a full-blown Linux operating system right here. So then I fire up the application, the amplifier again. I don't know if you heard the relays click there in the background. Alt F4 again. I'll just shut it down. I mean, so here I can pull up, the Chrome browser. Raspberry Pi is not as fast here, pulling a few things up, but I could pull up a bash shell, right? I mean, I'm in the operating system. In fact, I even installed. I'm digressing now, but I installed NTP, and so it's a NTP client now, so I've got an accurate clock going after boot up. And here's the Chromium browser running on your HF amplifier, your legal limit HF amplifier. Here I can go to RF-KIT. And the other thing you can do in the operating system, you can go in and set all your locale settings, set your time zone and all that stuff. I mean, it's not required, but you can certainly do that. So here I'm browsing RF-KIT right on my amplifier via VNC, and you can see that in the background. You can see the display change there. And I could go to groups.io. Yeah, I mean, why would you do this? It's just kind of fun to see. And I'd have to log in. But anyway, I mean, you get the idea. You could install, you can do all kinds of stuff. So the sky's the limit with this amplifier. I think that's why W4EEY coined it a software-defined amplifier. It's really a full-on, computer-defined amplifier. So this also allows you to gracefully shut down the Raspberry Pi. Maybe there's a way to do that on the app. I'm not sure. So I can shut down the Raspberry Pi, which closes VNC. The amplifier is still powered on, but the Raspberry Pi is powered off now. And I can turn the power off on the amp. So by turning the power off on the amp, I will end this video and get it uploaded. And hopefully you give it the thumbs up if you like it. I know it's verbose and goes into detail, but I've had a lot of guys glad I put this together. And again, don't forget to actually go look at the pictures on the website. I'll put that in the description, and we'll go from there. Look forward to part 3 when I do the calibration on the video. And thanks for watching. Bye.